This section examines the transfer case. In this application, the transfer case is bolted to the rear of the transmission. Drive is transferred from the transmission output shaft to an internally splined helical gear on the transfer case input shaft. This gear is constantly meshed with the larger of two idler gear pinions. They are constantly meshed with the high and low output pinions on the transfer output. The low-range output pinion is bolted to a differential case, which contains the third differential gears. The high-range pinion can rotate on needle roller bearings on one side of the case. The idler gear pinions are also separated, with the smaller low-speed gear free to rotate on needle rollers on the idler shaft, formed with the high-speed gear. A common selector fork links a splined engagement sleeve on the idler and a similar sleeve on the output. Moving the fork to engage high range locks the high output pinion to the differential case. Drive is transmitted at a 1:1 ratio through the larger pinion of the idler gear and the locked output pinion to the differential case. It is then transmitted through the differential gears to the front and rear output shafts. Engaging low range moves the selector fork in the opposite direction. This locks the low idler gear pinion to the idler shaft. From the transmission output, drive is transmitted to the large idler pinion and through the smaller locked pinion to the low-range output pinion, bolted to the differential case. This double reduction provides a low output speed ratio of 2.48 to 1 to both front and rear shafts. In addition, when low range is selected, a geared electric motor automatically operates an engagement sleeve splined to the front output shaft. It engages mating splines on the differential case. This locks out all differential action between the front and rear output shafts, so it should only be used in off-road situations. In high range, the differential lock is disengaged. Differential action is catered for by the differential gears located in the output case and splined to the output shafts. This allows for a difference in speed between front and rear wheels when the vehicle is on firm road surfaces.